All right, we are recording. All right, so we are moving on to another concept. This is pretty much the last major concept that we are going to talk about in this semester. So we're going to talk about two things. One is what the type is, and then the other one is what the structure is. So we're going to talk about types, and we are also going to talk about structures. This is a new module, by the way. I just published it because I had an older version of this, but it's not applicable because it was not written in C++, so I had to rewrite the whole thing. So we'll start with what a type is. Okay, so right here, a type in programming specifies a category of values. In other words, it kind of defines what you can and cannot do with a kind of, a category of values. So we have three types that we have talked about up to this point. One is called integers. Okay, so -5 is an integer, 20 is an integer, 0 is an integer, and so on. The next one is called a Boolean type. A Boolean type, which is spelled as Bool only instead of the full name Boolean, is a category of values that can either be true or false. And then the last one is a double, okay, which is the short form of the IEEE double precision floating point. And this is a category of values that are like real values or real numbers, like pi. You can represent pi. You can represent really gigantic values like the speed of light in meters per second. You can also represent tiny little values like the electrical charge of a single electron, and those are called doubles. So all three are what we call built-in types in C++, which means you do not need to define these. They are automatically known in C++. These are also called scalar types, or they're also called atomic types because they are elemental, which means they cannot be broken down into smaller components. So an integer is a whole integer. You cannot break it down. A boolean is a boolean. You cannot break it down into smaller components. And a double is kind of the same thing, at least not in programs in C++. So do we have any questions about the concept of a type? No questions. If you have any type of scripting experience before, in other words, you have written scripts in some other languages and whatnot, like Python or JavaScript, most scripting languages do not have types associated with variables. In other words, variables can change their type dynamically. Like one moment it can be an integer, the next moment it can be a boolean, and then the next moment it can be a string. So it can change over time. In C++ and most what we call strongly typed programming languages, a type is fixed. So that means that once you declare a variable that is an integer, it is an integer, okay, for the entire lifespan within that scope. So do we have any questions about this particular discussion of what a type is? We good? Okay, all right. So with that understood, we can now move on to a structure. So a structure is it's I use a longer paragraph to describe it. Okay, so technically speaking, a structure in programming is the packaging of multiple items into a single logical container unit. In other words, it's kind of like a form. Okay, if you think about a form, um, let me see if I can just pull a form so that you can see it. So we'll just go by the ARC forms. Okay, so we'll go for American River College. Um, let's just say that you want to, what would be a form that you typically need to access or use? Registration, maybe? Okay. So we'll say registration form. I'm not sure whether they even have a um, actual form anymore. So we'll check it out. Okay. Mm, nope. They don't have anything that's easy. Okay, so let's go for images because I think that's a better way to do enrollment. Okay, so we have some dual enrollment form here. This is a good one. Okay, so we'll. All right, so where's the form? Uh, hmm? I can't hear you. Sorry. Nope. Well, let me click on just the form itself. All right, so this is a form. Okay, may not be the same form that I want to talk about. Um, this is Indian River State College. Anyway, it doesn't really matter, okay, because it's really just a form. Um, so basically, what is in a form? So typically in a form, let's just say that you want to send a package, okay, at UPS or the USPS. So what typically do you need to fill in a form and go like, okay, I want to send this package by say UPS. What typically would be in a form like that? Address, okay. So it would be the address from, right, your own address, and then there will be the to address, okay. And then typically they also, they will fill in the part like dimension and also weight and stuff like that. So we'll take a look at UPS form and delivery form, okay. So we'll see whether this will. There we go. Okay, very good. So this is a form where you can fill in, the sender's name, phone number, email address, ship to contact name, ship to phone number, etc., etc., etc. Okay, this is kind of like a structure. Okay, so you go like, okay, so if this is a structure, what does it mean without a structure? That means instead of a single piece of paper with all of these multiple fields that you can fill in, and when you're all done, it's one go sheet of paper to hand over to the person on the other side of the counter. They give you a little pile of paper slips. Okay, on one tiny little paper slip, they will ask you about the sender's name. On another slip of paper, they'll ask you about the phone number and then the email address. Basically, you end up with, in this case, just what we can see at this point: one, two, three, four, five, six, 7, 8, 9, 10. They'll give you 10 little slips of paper instead of one single piece of paper with all of these fields. So that's what structures are for. So instead of giving you individual pieces of paper, which we call, which are our current variables, they give you one form, okay, where all of these things are logically grouped into one single thing. So when you're done with filling the form, you just hand over the entire form instead of a bunch of little slips of paper. So why do we need forms? Why do we need structures in this case in programming? So the reason why we need the same kind of concept in programming is so that everything stays more organized. Okay, instead of processing the address using one function, using processing, let's say, double checking the name field is valid using another function and so on, we can use one single function to process the entire form, but without having to pass like a bazillion parameters, when each parameter is only representing one little bit of the portion of an entire form. So it's for organization purposes. Without structures, programs can still be written, but such programs will become very hard to maintain and to become very prone to errors. Um, So a form, a structure is a form, but it is the form template. In other words, if you work in an office environment, and let's just say that they have a particular form for a certain thing, they typically keep a master form, which is something that you don't give out to people, so that when you need to print more copies of that form, this is the master copy. Do we understand what a master copy is in the case of a form in an office environment? We good with that? Okay. So a structure is the master form. Okay. It is not supposed to be filled in. It is supposed to be just a template. If you need to give somebody a form to fill, what you do is you walk over to the copier, you make a photocopy of the template, and then the copy is the one that you give out to the end user and go like, okay, this is the piece of paper that I want you to write down your name, you know, your address, and where's the to address destination, and so on. Are we good so far with that concept? Okay. So another way to look at this is cookies. Okay. So a structure is a cookie cutter. It defines the shape of all the cookies that you will cut using that cookie cutter. And what about the individual cookies that we use the cookie cutter to cut out, to cut out into? Those are called objects. Okay, so each cookie that you can eat is called a cookie, is called an object, or we can sometimes call those your structure instances. So when I use the word object or structure instance, they mean exactly the same thing. So are we doing okay so far? Distinguishing the template, which is also the cookie cutter, which is also called a structure, from what we can make out of the template or the cookie cutter or the structure. We good with those concepts? All right. So if we're good with those concepts, we can take a look at an example program. So this is an example of the definition of a template or the structure or the cookie cutter. So in this case, student record is the name of the structure itself. In other words, when you open up the drawer, you have many cookie cutters. So let's just say that, oh, okay, Christmas time is coming up, and you go like, okay, I want to use a Christmas tree cookie cutter. So now you can call out for the name of the cookie cutter called Christmas tree, as opposed to pumpkin, as opposed to, Valentine's Day or heart shape and stuff like that. So are we good so far with, the highlighted portion being the name of the cookie cutter? Okay. So what is in that cookie? Okay, what is the shape of this particular cookie cutter? It has got three members. Okay, so ID is the name of the first member. It has a type of an integer. GPA, on the other hand, is the name of the second member. It has a type of a double. And then active is the name of the third member. It has a type of bool. Are we good so far? Okay, so there are three components in this case to the structure called student record. They're called members, and the members are identified by name. So we have ID, GPA, and active, and all three have different types because the ID is just an integer. GPA would go from 0 to 4.0, but it is you can get like a 3.75 GPA. And then active is a Boolean, meaning whether the student is actively enrolled in classes or not. So it's a Boolean. It's either true or false. So are we still doing okay so far in terms of the definition of a structure, the template itself? Okay, all right, very good. So a template by itself or a structure by itself is not really useful, okay? It's just like, you have a collection of cookie cutters. So you have a collection of cookie cutters. Okay, it's not really useful. So it's only when you make cookies out of the cookie cutters that the cookie cutters become actually meaningful. So in this case, we have a sample program, okay, and we can actually copy and paste this and see it run, which is not a bad idea. But we'll talk about it first, and then we'll see it run in the debugger. So once again, we have the definition of the structure, which is the template. And now we have the actual code making use of it. So this portion here does not generate any code whatsoever, okay? Because you're not using it to do anything. This is just a cookie cutter in the drawer. So does it associate with any action at this point? Nope. All it is okay, we got some stuff in the drawer. So if you want to do something with a cookie cutter, which typically means you want to make cookies, right, out of the cookie cutter, that's when you do it like this. Okay, so this particular line is asking the compiler to go to the drawer, okay, and say, okay, go find yourself, the cookie cutter called student record. And well, we have that cookie cutter already defined earlier. And then what do we do with it? Cut out a cookie using some cookie dough. Cut out a cookie and call that cookie a rack. Okay, it's just a name. Okay, so a rack or a record is an instance that you make out of that structure definition. Is that okay? So let me double check and make sure that this is the name of the cookie cutter. This is the name of the cookie that you cut out of cookie dough using that particular cookie cutter. Are we good so far? So there are two names associated. Now, the other thing that is this one is more like a convention. Different companies may do it differently, but this is basically the de facto standard in industry. When you name a cookie cutter, you start with an uppercase character. Okay, so that's why student record in this case has an uppercase S instead of a lowercase s. When you use a name for the cookie that you cut out using a cookie cutter, it starts with a lowercase. Okay, it is just a convention. Okay, the programming language actually does not care. Okay, if you want to use all uppercase, fine, not a problem. If you want to use all lowercase, that's okay too. But in industry, this is kind of like a de facto standard. It is always nice to know, what is the industry standard, so that when you write some code and you want to showcase your code in an interview, you won't, the interviewer won't look at your code and go like, "Oh, you don't even know the industry standard. We're not gonna hire you." All right. So what are we gonna do with this particular program? There are only 3 lines of code. The first line of code looks like this. What does it mean? Well, we have a single equal symbol here, which means it's an assignment operation. It has the right-hand side and a left-hand side. The right-hand side is nothing magical. It is just a student ID. It is literally 1,920,416. That's just an integer value. The left-hand side, on the other hand, looks a little funky now, okay? Because most of the time, the left-hand side is really just a single name, but this time it has got 2 components to that name. We have arrac, which is the name of the variable, arrac here, but because ARAC is a student record, it also has a member called ID. So this means, if you look at the entire expression on the left-hand side of the single equal symbol, it means I don't want to change the entire record. I want to change only the ID member of the record of the student record um, known as ARAC. Are we good so far? Because a rack is of the type student record, and anything of the type student record has 3 members. The first member is ID, the second member is GPA, the third member is active. This particular statement, the one that's highlighted, is only going to change 1 member out of the 3, the one that is called ID. Are we good? So the next line, kind of the same thing, except this time we only want to change the GPA member of the entire thing, of the entire record. And then the last one is kind of the same thing, except this time we only want to change active, as a member. Are we still doing okay so far? All right. So as I promised, okay, let's go ahead and run this in GDB so that we can see what it looks like when you run the code. And let's see, we can use this window. It's kind of the font is kind of small. Okay, it's still gonna be okay. We'll go ahead and use this. All right, so we'll go ahead and we'll call this struct1.c because there are more to come. Paste that code, and then we do a gcc-g-o struct1.c. And then now we can debug the code. The debugger in this case is only used to illustrate things. So we're going to put a breakpoint on line 10, which is when we try to modify the first member of the entire structure. So let's go ahead and set up the breakpoint, run the code. So we are now just ready to run line 10. And in GDB, you can do something like this. So it would actually show you all the components of the structure instance that we call ARAC. So in this case, the member ID has an initial value of 0. The member called GPA has some really kind of funky, value. It's a tiny little value, by the way, because when you see E and then a negative, 310, what that means is times 10 to the power of 3 negative 310. So that makes it a very, very tiny value, very close to 0. And then active is, somehow has an initial value of false. Because we haven't really initialized this particular structure instance, so anything can happen. Okay, an ID only has to be an integer. There are many, many integers to choose from, and then GPA only has to be a double precision floating point number, and there are many of those to as an option too. Active, on the other hand, can only be true or false, but we don't know which way it is because it is still uninitialized. Okay. So now we can single step, okay? After we single step, we can print the entire record again, and you can see how ID is now initialized. The statement says, I want the right-hand side to be, 1,920,416, and now it is changed. But it doesn't change anything else, okay? Because this particular statement specifies that we only want to change the member called ID of the structure instance or object called AREC. Are we good so far? Any questions up to this point? We good? Okay. So if we single step, it means we are going to execute this particular statement, which means GPA is now supposed to change to 3.5. So we're going to single step, print AREC again, and now we can see, oh, okay, so this time it only changes GPA as a member, but the other two are not changed. Single step one more time, print AREC, and we can now see the active is no longer false, it is now true. Any questions about what we are looking at right now? We good? All right, very good. So the dot notation is pretty universal across almost all programming languages. So let me switch back to the lecture here. So the dot notation is basically the same thing as apostrophe S in English, which is the possessive grammar. So that means that AREC dot GPA can be interpreted as AREC's GPA member or the GPA member of AREC. So that's how you read using the dot notation. Are we good so far? All right, excellent. So now we're going to trace the code, but using an actual trace. Okay, it is not the same code, but it is. Oh, I see what I'm doing here. I forgot to kind of put this code into the right place. Ugh, okay, that is not what I wanted to do. Okay, so I'm going to trace this code, using a spreadsheet, and then I'll have to kind of update um, the notes here. So what we'll do is we're going to copy and paste this into a spreadsheet, which I have already constructed at this point. But we'll start a new one. I think it's better to start a new one. So start new, and we want a sheet, but we want to get it from a template this time. Okay. All right. So this is the template that I want. There we go. All right. Um, All right. So first of all, I'm going to paste the code over here so that we have line numbers. And then what we do is the usual, which is you're copying and pasting this code into the program. This one is fairly short, so I think we can just do this. And then we go back here, paste the image over here, like so. And now we can trace the code. And we'll change the name of the file from template to today's date, which is 2025. And today is 11/17. There we go. All right, so from this point on, we're gonna have this particular format. We start execution on line 7, doesn't really do a single thing. Line 8, on the other hand, is now doing something that is kind of interesting. So as it turns out, within a structure, for every member that is a elemental type or scalar, you need a column. So that means how many columns do we need in this case for a rack? 3 columns, that is correct. So we need 3 columns, and the way I document those 3 columns is something like this. Give me a second here. So the way I'm going to document the 3 columns is going to be a rack, okay, which is the name of the variable itself, and then a dot, and then an ID that has its own column. And I don't know how to make sure that it does not interpret it as a, because ID is, can be a domain name, and that's why it's in blue. And then the other one is going to be arac.gpa, and then the next one is arac.active. So you can see how arac actually takes up 3 columns, 1 column for each scalar type. ID as an integer is a scalar type. GPA as a double is also a scalar type, and then active as a boolean is also considered a scalar type. So we need 1 column for each one of those, because if we don't do anything like this, then when we update a particular member, which column am I supposed to modify? So that's why each one needs a single column. But they are all unknown to begin with, just like any variable. When you first declare, they start with unknown values, and then we move on to line 10. Line 10 says, the ID is going to change from 1,090 to 1,922,416, but it doesn't make any changes to GPA nor active. It only changes the member called ID. Line 11 changes GPA as a member to 3.5, and then line 12 is going to change active to true from whatever it used to be. Okay, we don't have any idea what it used to be. And then we get to line 14, and then we get to post. I forgot to make a row for pre, which is not really necessary these days, but we'll just put it over here. All right, so let's just take a quick look at the trace. Do we have any questions about this trace? This is all good. So the most important part is each member that is a scalar type needs its own column in the trace. Okay, and this is the way that I name it. Now, if you say, okay, I want to do some fancy, formatting, okay, that's fine. Let's do some fancy formatting here. So if I want to do anything that is kind of fancy, I would do something like this. Now, visually speaking, it is a little bit better, but you don't have to do it. So that means I'm going to call this ARAC, and then underneath I have ID, GPA, and just active. Whoops, that was unintentional. So this is just active here. And then I would use cell merge, okay, to do something like this. So I go to format, I go to merge cells, merge all. So this one is a little bit fancier, okay? I don't need you guys to do something like this, certainly not in an exam. The reason why this is kind of fancy, but it is kind of also visual, is when you look at ARAC, it already tells you that ARAC by itself is referring to all 3 columns: column C, column D, and column E. But when you want, put a particular member ID, well, that's just column C. If you want a particular member GPA, that's column D. If you want another particular member which is active, it is yet another column. So this is a nicer way to look at a structure because it is graphically showing you that a rack takes up all three columns, but each member is only taking up one column out of the three. So are we still doing okay so far with this? Okay. So if you want some even fancier stuff, we can color code. That's kind of up to you. I mean, you don't have to do it like this, but I think if you have the time, mm, it's kind of nice to understand that a rack is referring to all three columns. All right. So any questions up to this point? No questions? We good? All right. So then we're going to look at something that's a little bit fancier. So what is fancier is now we have a structure inside another structure. So in this case, we define a cookie cutter or structure called academic. So academic only has GPA and active. It doesn't have the ID. Is that okay? But then when we define the student record, this one has the ID just like before. But when you look at A data as a member, it is not going to be of a scalar type. This time, A data as a member itself is an instance of a structure. Are we good so far? So we are looking at nesting in this case. We can have a structure that is nesting another structure as its own component. Are we good? All right. So when you look at the actual code, okay, when you look at the actual code, this time when we want to assign the 3.5 of a GPA, this time we have to specify a little bit longer. A rack is the name of the structure instance. A data is a member of a rack, but because it itself is a structure, now we can also say, oh, the GPA member of the A data member of the variable A rack. So that's why we have two dots in this case, and that specifies where we need to make the change. So I'll just let you guys kind of look at this a little bit, see if you have any questions before I trace it. So we have two cookie cutters in this case. The simpler cookie cutter is called academic. But the second cookie cutter, which is the bigger cookie cutter, is incorporating the first cookie cutter as a part of it. Yeah, it's the other way around. The first one, academic, is the smaller one, and it gets incorporated into the bigger one. Okay, so now we're going to take a look at how this is represented in the trace. Okay, so let's go ahead and take a look. This one is actually pretty easy. Okay, so what we'll do is kind of the same thing. Let's go back to the code here. We are going to copy and paste it to introduce the line numbers. Okay, so copy and then go to my editor here, start another one, paste it here, and make sure that we cover everything. Okay, like so. And then copy to clipboard, that's fine. All right, so now we go back to the spreadsheet. So this time I can do something rather kind of lazy. All I need to do is to duplicate sheet 1 into sheet 2. So we just call this sheet 2. And sheet 2 is going to correspond to the new code. So we're going to put this new code over here. But when we need to document what is going on, we need a little bit of change, but not a whole lot. Okay. So in this case, all we need to do is to say, we're going to add one more row here. Okay. So we're going to add one more row below. In this case, these two. Okay, needs to go down one level, and then these two cells will combine or will be merged. Okay, format, merge cells, and then this one will now be called A data. So now the rest of the program doesn't really need to change other than the line numbers. So we have to adjust the line numbers. We start on line 11. This is what line 12 is going to do. 14, 15, 16, and then finally we have line 18. But otherwise, the program really does not change in terms of how it changes the columns. So let's go ahead and check this out, okay? Find out, what it is actually doing. So A data, okay, I'm going to also put a little bit of color over here just so that it is kind of distinct. So now we can see how A rack is the name of the entire thing. It occupies columns C, D, and E. A rack has two members, okay? So this is the most important part. A rack, because it's a student record, it only has two members. The first member is called ID. The second member is called A data. ID is an integer itself. It takes up one single column, which is column C. On the other hand, A data is an academic. It is by itself a structure. So that's why A data takes up two columns. Are we good so far? But if you want to look into A data, you will find out that, oh, A data as a member has two sub-members. The first sub-member of A data is called GPA. The second is called active. So that's why the organization is like this. So we're gonna let it sit for a little bit, okay, and see if you guys have any questions. A structure is kind of like a folder. Can you have a folder inside a folder? Yeah, basically that's what it is. Okay. So one way you can kind of visualize, all of this is, let me see if I can just do that. Okay, I'll go ahead and see if this helps a little bit. Okay, and I'm just doing something offline so that by the time you see it, it won't be confusing anymore. Um, okay, we can use exactly the same name, student rack. All right. Okay, I think this is good. All right. So using a file system like an example, so in student rec as a subfolder, can you guys all understand, the file navigator thing and understand what a subfolder is? Okay, very good. So under student rec, we have two items. We are going to create a single file. Okay, so we're going to say file, let's see, new tab, create file. Nope, I can't do that. Create document, that's all we need. Empty file. And this empty file is corresponding to a scalar type. So the scalar type is the ID. ID is an integer, so it's a scalar type. Okay. What about the other component? What about A data? A data is another folder. So now we're going to create a folder inside this particular folder called A data. Are we good so far? Now, the ordering, I can't really enforce that when we're looking at files, but do we understand from the perspective of the number of components? A student rack only has two components. One is called ID, the other one is called A data. Now, because A data is by itself an academic type of record, so in here, we're going to have two documents. The first document is called GPA. Okay, I would just call it a text file if that part is not important. And then the other one is whether it's active or not. So we're going to create another document here, and this time we'll call this one active.txt. Is that okay? All right. So when we get back to the temp folder and we look at student rec itself is a template. Okay, so that means if you want to create a variable out of this type, what do? You make a copy of the entire folder structure. So that means in our case, It's called ARAC, right? Okay, so that means I need to make a copy of the entire folder. I copy and then I paste, and the new copy, oops, has exactly the same structure, but I need to rename this as ARAC. All right. So what do we have in ARAC? ARAC has got an ID, but this time, because it is no longer a template, I can now go into this text file, change it. Okay. I can say the ID is a particular number. Okay, so we'll just kind of type some random number here. Save the file. Oops. Oh, I just did something other than what I intended. Save the file and then close it. So now when we look at the file, it actually has content now. And then we can also go to A data and go like, the student is actually active. So now we can change this and say the student is actually active. It is true. Save the file. And now when you go back to the file navigator, you can see that the active.txt file has 4 bytes, which spells out true. And then the GPA, kind of the same thing. We just say, okay, the student, corresponding student has a GPA of 3.5. Save it again. And then when we get back to the navigator, you can see how GPA now has 3 bytes, which is exactly 3.5. So is that helping to understand, how the whole thing is organized? hmm So being able to include a structure as a member inside another structure is really helpful. Okay, this eventually leads to what we call object-oriented programming. Okay, have you guys heard about that term? Object-oriented programming. Nope. Okay, that's fine. So we can look it up a little bit, okay, and we can ask for a kind of like a simple definition of what is object-oriented programming, okay? So now we go to, say, Gemini, and you all have access to Gemini now, okay? The entire California community college system has paid for 3 years of subscription so that every student will have Gemini access for the next 3 years or so. So sign into your 7-digit at apps.losrios.edu, and then you just go to gemini.google.com, and there you go. Okay, that's how you access Gemini. You can use it for a lot of things. For instance, in this case, you can ask, okay, define object-oriented programming in simple terms. Okay, so one thing about using AI is you have to give it enough context. If you want it to give you some usable results, you have to give it a lot of context. So now you can mention what class you're in, okay? Because otherwise it can give you like a 6-paragraph explanation involving concepts that we haven't learned. So you can give it a little bit more context, okay? So you can say, I am in an introduction to computer uh, introduction to algorithm class, and we just discussed the concept of struct. Okay, I put backticks here because it's a keyword. Um, okay, so that gives it a lot of context, and then we just kind of let it go. Hmm? It's a keyword means that word in the program has special meaning, just like if, just like while, just like do, it has a special meaning. So typically, the backtick symbol is used to make things look verbatim, which means it has a kind of special kind of font effect where it is a fixed size font, so it stands out as a programming code word instead of just an English word. So it's a formatting thing. You don't really need that, but to make it stand out a little bit, I personally like to use the backtick. hmm All right, cool. That's a good question. And you just kind of click it. I'm using the pro model, but for something like this, you don't really need the pro model. If you wanted to kind of give you some really quick answer instead of having to wait, you can change it to the Flash model. All right, so this is the explanation. Object-oriented programming, which is also usually kind of abbreviated as OOP, is a way to design software by building data and the function that works on that data into a single unit called an object. Since you just learned about struct, here's a simple way to think about it. So this is how it is useful to give it a context because it tells you how to bridge from the struct concept to object-oriented programming. Mhm. All right. So it gives you, an example, lots of, it does use pointers, unfortunately, which we haven't really talked about. So, it doesn't quite gauge, how much is already introduced. So now you can say, now, if you encounter something like this, you can say, okay, this construct is not introduced yet. Okay, you can just kind of in the prompt say exactly that. Okay, uh, my class has not explained this notation, and then put it in quotes, okay, so that it is clear cut, which part you're talking about. Okay, particularly what the what this means. Can you explain OOP without this notation? Okay, and I have some typos here, and I have a Grammarly to fix everything. Okay, so yep. Oh, oh. Thank you. Explain this notation. Thank you. That's a good catch. All right. So I'm at this point I'm just illustrating what you can do with Gemini. Now, obviously, some people will use Gemini to do their homework, okay, which is not a good use of using AI. But using AI in this way, kind of just kind of do some back and forth, query, read the answer, query again. That actually is useful. Okay. Yep. Yeah, I actually made one like that for this class. Yep. So from struct object, a simpler way. Okay, so there we go. So basically, object-oriented programming means I mean, you can read the rest. I'm not going to talk about object-oriented programming. This is just an illustration of what you can do with using AI. Yep. You can look forward a little bit. You can look backward. Like, okay, I'm not really sure what this, No, object-oriented programming is two classes away from here. So after this class, you'll be taking Cisp 360, which will continue to only use structs, okay, or structures, but it won't cross over to object-oriented programming. It's only in Cisp 400 that you will encounter your structures. I mean, object-oriented programming. Yep. So this is way ahead of us. Okay, we are at least 2 semesters ahead, in terms of this type of material. Yep. But the point is, it ultimately connects to those concepts. Structure is the basis of object-oriented programming. Okay. All right. So this is another program. This one illustrates the nested use of structures. We have a bigger structure making use of a smaller structure as its own component. So are we clear on that concept? Okay, we good? All right. So if this is good, now we look into assignment operations. Okay, so this is a trace for the first one. It's unfortunately it's not the second one. But when we look at this, let's take a look at this program here. Okay, because I'm just making those programs, incrementally more complex. Okay, so with this program, it doesn't really change a whole lot of things. When you look at how academic is defined, same as before. If you look at how student rec is defined, same as before. But when you look at the main program here, Now we have two variables. The first variable is the same as before, which is just a rack, okay, a record. And then we have a second one, which is a CAD, which is of a different type. It is of the structure type of academic. So that means, what do we have here? We are making two cookies in this case. The first cookie is the same kind of cookie that we have been cutting out, okay, since the beginning of this class. The second cookie is a little bit smaller. The second cookie, called a CAD, is using only the smaller cookie cutter to cut out of it. Okay, so we have two pieces of cookie, one bigger piece, one smaller piece. Are we good so far? Now, but there's one more thing. The shape of the smaller cookie that we call a CAD is matching a part of the bigger cookie, which is A data. Why? Because A data has a type of struct academic, and a CAD also has a type of struct academic. So that makes those two pieces of the subpart of the larger cookie called A data, that's the member, and the second piece of cookie, which is called a CAD, they have exactly the same shape. What shape are we talking about? It has got a member called GPA, that is of a type double. It has a second member called active, which is of the type bool. Are we doing okay so far? All right. So now something magical can happen. So what we do is now we don't initialize, or we don't put a value into a rec directly. We put a value into a CAD instead. So a CAD itself is initialized using these two statements, okay, which means GPA gets 3.5 and then active gets true. Is that okay? It doesn't matter. It does not matter because the ordering of the definition can be in any way. It just means in terms of the columns, are they to the left? Is one to the left or to the right of the other one? So that's all it is affecting when you change the ordering of the definition of the variables. Sort of. Okay, sort of. Yeah, so I think I have a second trace of this. Okay, so this is the other trace. So we can work on this trace, kind of manually in class. So this way it's step by step. I'm just trying to explain the code first, and then we'll go for the trace. Okay, so these two lines, which is a CAD.GPA gets 3.5, a CAD.active gets true. These two lines is only initializing the smaller piece of cookie, which is a CAD. Once that is done, I now have a really kind of confusing line over here because instead of doing an assignment for every smallest field or member, I now say, hey, look at the larger member called A data of A rack, which is by itself not a scalar type, it is of a structure type. We can now change the entire thing at the same time. Okay, so let's go ahead and take a look at what happens when we trace the execution of this code. Okay, are we good so far? Okay, so we are going to just gonna copy and paste this so that we have we can add line numbers. This over here, and I think I don't need this anymore, so we'll just overwrite this portion. Now that we have line numbers, we can take a snapshot like so. There we go. I think we can still show the entire thing inside the trace, so we'll just kind of paste it on this side. Maybe we're pushing it a little bit. We'll see. Okay, paste over here. Yeah, we're pushing it a little bit here, but I think we're still okay. There we go. All right. So now that we have the whole thing here, we'll just kind of go back, and the comments is of no use in this case. The precondition has nothing to say. Line 11 is main. So on line 12, technically speaking, on line 12, we're only reserving the space for A rack. So what is an A rack? Okay, an A rack has two components. The first component is called ID. The second component is called what? A data. That is correct. But A data also has two components on its own. The first one is called GPA, and the second one is that is correct. So if I want the most fancy way to do this, I'm going to format it accordingly. Okay, so merge these two, just like before. So this part has not changed. Okay, so we just talked about this one before, but everything are unknown to begin with. So we still have to put question marks over here because they're technically unknown at this point. So this part is not changed from before. We good with this? All right. So now when we move on to line 13, okay, so we can actually shrink this one too. There we go. So when we move on line 13, we are making another cookie. This time the cookie itself is called a CAD. How many columns do you think a CAD has? A CAD is of the type struct ac ac academic. Only two. Very good. So the first member is called GPA. Exactly. And the second member, active. That is correct. So a CAD, as another piece of cookie, only takes up two columns, column F and column G. So we're gonna do some fancy formatting here, which you don't have to do, but since I do have the ability to do it, that makes it a little bit more interesting. Okay, so a rack as a single piece of cookie has a few components. It takes up three columns. Okay, so just like before, I'm going to use some color coding here. A CAD, which is our second and smaller piece of cookie, takes up only two columns. Are we good so far? And they're both unknown to begin with. Okay, it is very important to specify that they're both unknown. Are we good so far? We're only up to line 13 of the code. Okay, so now we move on to line 15. Line 14 is empty or blank. So we move on to line 15. Can someone tell me which column is going to change to 3.5? It is the GPA of a CAD. So which column would that be? Column F. That is correct. So this changes to 3.5. What about line 16? Which column is changed? Column G. Yep, yep. Column G changes to true. There we go. Now, so those two are not really interesting because we have seen stuff like this before. So what is happening on line 17 then? So line 17 is kind of funky because it says take a cat as a whole piece of cookie. I'm not talking about a particular member of the cookie called a cat. I'm taking the entire piece of cookie called a cat. On the right-hand side of the assignment, we are referring to a cat here, right? The entire piece of cookie. What about the left-hand side? The left-hand side is now saying, okay, take a look at the part of ARAC, the member called A data. Okay, so we are looking at A data in this case, and this is the right-hand side, this is the left-hand side. The right-hand side specifies two columns, F and G. The left-hand side, guess what? Also specifies two columns, in this case, columns D and E. Is that okay? And without having to name and go like, okay, the GPA goes to the GPA, and then the active goes to the active, it gets it done without you having to specify the individual assignment of the scalar types, of the scalar members. Okay, so now in one single line on line 17, we are now saying, oh, okay, the GPA goes to the GPA, and then the active goes to the active. Done. This is the first time of this entire class that we can see multiple columns getting updated because of the execution of one single assignment statement. This is really helpful, okay? Because it saves you the trouble of having to say arac dot adata dot gpa equals to acad dot gpa, and then followed by arac dot adata dot active equals a CAD dot active. hmm So, but these records are small. Okay, it only has like 2 or 3 members, right? 2 members actually right now. What if your record has like 20 members? Don't you think this is saving you a lot of time? Exactly. So this is the interesting use of structure in a nesting way. Okay, because you can now treat an entire subpart of one larger thing. Go like, okay, we need to copy this over here. It will copy the whole thing. Okay, so this is really cool. So the rest of this, not very exciting. Okay, line 18 is still just going to change ID by itself, 1729384. Okay, so column C by itself is changed, on line 18, and that's it. Okay, we move on to line 20, and then we get to post. That's the execution of this entire program. Any questions? No? Okay, all right, very good. It's 10:02 right now. So now, if we don't have any questions about the straightforward use of structure, we're going to move on to talk about something that I have not yet typed into the notes because I was running out of time this morning. So what we'll do is talk about how to pass a structure as a parameter. So we need a function and then we need to pass it as a parameter. So I'll go ahead and write the program first, and then we'll come back and take a look at what happens when the program executes. Is that okay? All right. So we'll go ahead and actually I have the code already written. Okay. Is it here? Yep. Okay. So this is the code that I have written. Okay. And in this case, let's make this a little bit more interesting. Okay. So I'm making this a little bit more complex. Okay, in a certain way, but it's not really that much more complex. Okay. Arag dot a data here. Okay. And then we can now take this out. The program actually gets shorter, but it illustrates a more complex concept. Okay. So we have about the same thing. The first, the definition of academic as a structure doesn't change, same as before. The definition of student rec also has not changed, same as before. When we have a variable inside main called arag, which is of the type struct student rec, that also has not changed. So all of those elements have not changed. What we have introduced in this case is a function. This is a new function. It is called init or initialize acad, which is the academic portion of something. Let's look at the 3 parameters. This is the first parameter. So the first parameter looks kind of like, okay, we haven't seen anything like this before, but we have seen the individual parts of this whole thing. So we have seen how we use struct academic to basically say whatever it's following is of the type that is a structure of academic. We have seen that before, right? How to make use of the structure definition to say, okay, this thing has this shape, basically. We have seen this also individually, which is passed by reference. The ampersand is a signal or is a notation to say that this parameter is passed by reference. We have seen pass by reference when we pass an array as a parameter. Okay, so it's the same concept. The other two are pretty run of the mill. GPA is a parameter. It has a type of double. Active is a parameter. It's a type of bool or boolean. And the inside, we say, okay, we are going to change the GPA member of a CAD as a parameter to the value of the parameter GPA. So this looks a little confusing because we're using GPA in both cases. So the important part is if GPA appears by itself without being a part of a dot notation, it is referring to a parameter in this case. So this GPA refers to the parameter GPA over here. But this particular GPA, which is after the dot notation, means, oh, I am just naming a member of something. The member of what, right? So it is a member of a CAD. Is that okay? Well, it's perfectly okay because a CAD as a parameter, even though it's passed by reference, but it doesn't change the fact that a CAD is a struct academic. And guess what is in a struct academic? GPA is one of the members. All right, all right. So we're going to run this code, okay, using a trace, and then we'll kind of examine what happens when we run it. Are we good so far, or do we have any questions about the code so far? Okay, so we are good to start the trace. Okay, all right. So we're going to do the same thing, which is taking a screenshot of this. I think this one is going to be a little bit more, it consumes a little more space. Okay, so we might need some scrolling when we get to the trace, but that's okay. We can handle that. So we go back to here, add another sheet, and then paste the bitmap and just kind of slide it over here. We can also change the size of the source code a little bit. As long as it's still readable, we're okay here. All right, so we got comments, not really useful because we don't have any conditions to evaluate. We have line number, useful, but doesn't need that much space. So we're going to start with pre, doesn't have anything to do, line 16, line 17. So this time we only have a rack, which takes up 3 columns. So a rack takes up 3 columns. The first column is ID. The second and the third column together is A data. Okay, so we're gonna do the fancy stuff here, right? You know, go to format, merge cells like so, and then merge these three also. Here we go. All right. So ID is by itself, it is unknown. A data, on the other hand, is a struct academic because you can see how A data is of the type, struct academic, which is defined over here. It has one scalar type member called GPA, another scalar type member called active. So this part has not changed. Okay, it's still the same stuff as before. So because all of these are unknown, we just kind of stash question marks all over the place. Are we good so far? Okay. So now we shrink the columns a little bit because we need room for what is to follow. So now we move this one over a little bit like so, and now we get to line 19. So here's line 19. Line 19, we can just use, instead of using return info, we can just use return line number because there's nothing else to do on line 19 once the invocation of the function is done. So we don't need return info, which is just, we can use the simpler return line number in this case. Okay, so we just say, okay, fine, we'll use return line number, and that's going to be line 22, line 20, you're correct, line 20. Okay, that's the easy part. Now we need to specify the parameters. So it has 3 parameters. The first parameter is called ACAD. The second parameter is called GPA. And then the last parameter is called active. We good so far? So how do we know the parameters? They are here. So when you look at the first line of the function definition, it will show you all the parameters, comma separated. So we can see a CAD is 1, GPA is 1, and then active is 1. Are we good? Are we supplying the correct number of arguments? Because when we have 3 parameters, we should specify 3 arguments. Yep, we got 1, 2, and 3. Okay, very good. So let's deal with the easy ones first. GPA is passed by value, same with active. They are both passed by value. So we just have to specify those particular values to the columns corresponding to the parameters. Yes. Oh, that is my mistake. Thank you. So that is supposed to be a comma here. I forgot to put it there. Yep, thank you. So Yeah, so we can, let me see. Let me go ahead and fix it first because I hate to leave things unfixed. Okay, so we'll go ahead and fix it like this and then just take another screenshot. Yeah, thank you. That was very good. Yep, so we just take this, okay, copy, and then paste it. Let's just say paste it over here, and then shrink the size just like before so that it fits. We don't have to scroll around too much. Well, those are the important parts. I think we're good. All right. So the big question is, what do we put over here? In other words, we are using areg.addAdata to specify the parameter ACAD, but we know it's passed by reference, which means the parameter ACAD only needs to refer to the first column of whatever the argument is specifying. So that means the first thing we need to do is to find out what is the first column corresponding to the member called AData of ARAC, which is a structure instance. So can someone tell me which column refers to is the first column of the AData member of ARAC? Column D, that is very good. Okay, so this is now basically a reference to column D. Okay, it is not column D itself. This is column G. Column G is not column D, but column G is a reference. It is saying, don't look at me, look at column D. Okay, that's what it's saying. Okay, it is saying, if you want to find a record, don't look at me, look at column D. Column D is the first column corresponding to the record ACAD. Okay, ACAD is the name of the parameter. Okay, so now we have all the columns set up. We can now continue to move into the function on line 11. Doesn't do a single thing. Let's go to line 12. Okay, so what is line 12 doing? Line 12 is an assignment operation. It has a right-hand side, has a left-hand side. I always evaluate the right-hand side first. Okay, so the right-hand side says, okay, give me GPA. You go like, but there are many GPAs in this case. Which GPA are we talking about? First question, do we have a dot in front of the GPA? Not on the right side. So that means it is not referring to a member of anything. So if it's not referring to a member, it's just referring to the parameter called GPA. So do we have a parameter called GPA from the trace? Yep, column H, which is 3.5. Nope, this is it. Because this one is a member. Yeah. So this is it, okay? So we now know that the right-hand side of line 12 is really just 3.5 because that's the value because it's a parameter, right? So it has a value of 3.5. What about the left-hand side? So the left-hand side is a little bit funkier, okay? Because to read the left-hand side, the first thing we need to go is like, okay, what is a CAD? Of everything over here, column G is a CAD, okay? And it is a reference to a struct academic, okay? So that means, oh, if you want to find the structure, don't look at me, look at column D. Column D is the first column of a struct academic, okay? So we now look at column D and go like, hey, column D, are you really the beginning of a struct academic? What is unique to a struct academic? The first member is called a GPA. The second member is called active. Okay, it's cool. And now we go like, okay, but I don't need the whole record. I need only one member of that record, of that structure. Which part do we need? The GPA member. So now we go like, okay, I see that we only need column D. So column D is now changed to 3.5. Is that okay? No. So on line 13, nothing too kind of exciting. It is column E that gets updated to true. Are we good so far? Okay, so a cat only helps you find the first column corresponding to the structure instance, and then the member that you specify after a cat helps you identify. I may or may not want the first column. Okay, I might want to refer to the second member by name, but the structure itself or the structure instance itself, which is in this case, it starts with column D, but it also has column E. Okay. So now when this is all done, we get to line 14. Line 14 is just going like, okay, we don't need these columns anymore. And then we continue execution on line 20. So we put line 20 over here. Oh, actually, we need to skip one because I need to indicate that these are all deallocated. So copy, paste, shift, alt shift 5. There we go. We get on to line 20, which is just changing the ID member of ARAC, which is column C. So that is now 1729384. Okay. And now the program completes because we get to line 22, which is our return 0. And then we get to post. So I will document this. Okay. So this part is not documented yet in the module because I kind of ran out of time this morning, but I will put it over here. But whatever I put here is nothing more than just a verbal description of what we did already in class. Okay, so the lecture itself is actually the more important part. hmm And it might be helpful to kind of jot down some notes. Okay, once we because we have the screenshot already, and all of you have access to this particular spreadsheet. So I think that's one thing you can do. Either print this out, okay, put it into your notes, or if you prefer to keep everything digital and only print things out here when in right before an exam, you'll make a copy of this, go to File, go to make a copy in your own Google Drive in the folder for this class, then you can start to annotate it, add your notes. All right, so perfect timing. It is 10:18. Thank you for being here, and we'll continue this discussion on Wednesday. Yep, very good. Yeah, go ahead. Yeah, yeah, so it is all the way up here, okay? If you go to course information, oh, okay. So it is all organized by date. So you just have to look up the CISP 300. Like this is the one from last, let's see, '05 is, okay. Exam 2. Oh, okay. 8 to 9, which is right before the class. Yeah. Yeah, I'm in my office from 8 to 9 every day. So if you want to meet with me tomorrow, that's fine too. Oh, wow. Okay, that's a long drive. Okay, all righty. See you on Wednesday.